I've had some questions about graphing linear inequalities, and I am including in the Blackboard announcement for this presentation part of your textbook, a page from your textbook that has the steps that I'm going to go through, as well as an example for you to look at. So I'm going to work through the inequality x is less than y. So that is our inequality. And the first thing, there are three major steps to graphing a linear inequality. You have to graph the boundary line, do a checkpoint, and then shade the appropriate area. So as far as graphing the boundary line, we can't graph an inequality. However, we can replace, so I have the word replace here, the inequality symbol with a equal sign. So then we have x equals y, and that is an equation that we can graph. Now, there are three methods for graphing any line. You can plot points, or you can use intercepts, which is when x is 0, find the y, or when y is 0, find the x. The third way is to use the slope-intercept form of the equation, but most likely with this one you're just going to plot points. So that means that I'm going to choose a value for x and determine the corresponding value of y for that x. So I like -1, 0, and 1 because they're usually pretty easy to calculate. And if we look at our line, x equals -y, if x is -1, then y is -1 as well. There's our first ordered pair. If x is 0, y is 0. There's our second ordered pair. And if x is 1, y is 1. And I like to have three ordered pairs when I'm graphing on paper. Of course, MathLab only lets us do two. But you can do the third point and then just look at the graph to make sure that everything is lining up on the same line. So we have found the points, and then the third step under graphing the boundary line is the type of line. And that means, are we using a dotted line or a solid line? Because that makes a difference. And we determine that based on the inequality symbol. So when we go to the next screen and actually graph this, we'll talk about what type of line. And then step 2 and 3 we'll also see on the next screen, but to use our checkpoint to determine where we're going to shade. So there's our 3 points, -1, -1, 0, 0, and 1, 1. So now I'm going to go to a coordinate plane, and remember our points were -1, -1, 0, 0, and 1, 1. So there's my 0, 0. There's my 0, 0, and there's my 1, +1, +1. There's my -1, -1. And then I need to determine whether I use a dotted line or solid line. Now we had x was less than y. Remember that when you have a less than or a greater than, that you need to use a dotted line, because that means the points that are on the boundary line are not part of the solution set. So if it's a less than or a greater than, then you will use a dotted line. If it is a less than or equal to, or a greater than or equal to, then you're going to use a solid line. So just a regular line that we're used to doing. So now on this particular x less than y, this particular inequality, we have a less than, so that means we're going to use a dotted line. So there's our boundary line. That means all the points that lie on that line are not part of the inequality. And then the second step is to use a checkpoint so that we can do the third step, which is to do our shading. Now, checkpoints. Checkpoints are just something that you choose to substitute back into the original inequality to see whether or not it's true. So how about and it can be any checkpoint. I'm going to do 2 for you just to illustrate. But how about we look at the point 3, -3. So let's look at this point right here. This is x is 3, y is -3. And then let's also look at the point x is -3 and y is +3. So this is -3, +3. And let's start with that one. So we substitute these coordinates back into our initial inequality, which was x less than y. So when we substitute, we're saying is -3, which is our x, less than 3, which is our y. Is that a true or false statement? Well, that is a true statement. So that means everything on this side of the plane, on this half plane, on that side of the boundary line, everything on that side is part of the solution set. And you could choose other values in there and check them to make sure. So what if we did negative 1, 2, 3, 4, 5, -5, +5? So we would be checking, is -5 less than +5? And that is a true statement. So what if you don't choose the right side? Well, if we use 3, -3 as a checkpoint, since we have x is less than y, then we are checking, is 3 less than -3? Well, that is false. So since this point, 3, -3, is not a solution to the inequality, nothing else in this half plane, nothing else on the right side of the dotted boundary line will be a solution to the inequality. So I hope that helps. Let me know if you have any other questions on these inequalities.